This is an oscilloscope. It displays voltage on the Y and time on the x-axis, allowing you to view electrical signals as waveforms. Right now, it's connected to a function generator that is outputting a sine wave. We've connected the function generator to a multimeter to demonstrate how the oscilloscope works. You can see the voltage changing from 1 to -1, like a sine wave. This is what the oscilloscope reads and displays. Now the function generator outputs a sine wave to channel 1 and 2 of the oscilloscope. By giving one of the sine waves a 90 degrees phase shift, we get a sine and a cosine wave. While sine and cosine are nice to look at, they're not very interesting. So, by changing the oscilloscope to display voltage on both x and y axis, also known as XY mode, we get more interesting images. Here is the simplest example, a circle. The easiest way to explain how this works is visually. You can see how cosine is projecting onto the x-axis, and the sine wave in red is projecting onto the y-axis, creating a circle. It is also important to know that any waveform can be created by summing up sinusoidal waves. Here we have the square wave as an example. It is not actually a square, but the addition of many sine waves. The sum of a series of sine and cosines to create other functions is known as the Fourier series. It is what is used to calculate what sounds and additions of sounds will create certain shapes. So how does all of this relate to sound? Sound waves are sinusoidal waves. So we can connect a microphone to the oscilloscope. The microphone will then convert sound to electrical signals, allowing us to view sound waves. Another way to do this is by connecting the oscilloscope to a computer. Here we have an auxiliary cord. You can see that the plug has 3 sections, the tip, ring, and the sleeve, each corresponding to a wire. The red is the left audio output, the white is the right audio output, and the black is the ground. By connecting each wire to 2 B and C adapters, we can get the right audio output on the x-axis and the left audio output on the y-axis. The oscilloscope will then display any audio played by your computer. There is music specifically made to be viewed on the oscilloscope. Here is an example by Jeremy Benderson.